So good afternoon, and thank you for joining us for today's webinar. My name is Jessica Katz, and I'll be your host for today's session. We're about to get started, but first, I just want to let you know that this session is being recorded. So if you miss anything, don't worry. We'll be emailing a copy of the recording so you have it as a resource going forward. If you have any questions at all during this presentation, please type it in the chat box, but know that all questions will be addressed at the end of the session during the QA forum. Today's webinar is brought to you by MPSA as part of their Machine Safety Series. MPSA, or the Machine and Process Safety Assessment Group, is a division of Airline Hydraulics Corporation. Since 1991, MPSA has been specializing in helping companies develop their machine safety programs by offering risk assessment training and turnkey machine safeguarding solutions. This includes design, fabrication, installation, and system validation. You can learn more about MPSA by visiting www.mpsasafety.com. Today's presenter is David Kerr, MPSA's EH&S Program Specialist. David has over 35 years of global EH&S experience. He has been part of the MPSA team since 2017. After retiring as Director of Global Safety and Loss Prevention for Merck & Co. Inc., he continues to make the workplace safer by assisting MPSA clients with implementing machine safety improvement programs. And joining us as a panelist, we also have MPSA's Senior Controls Engineer, Jamie Gehring. He has over 45 years of machine design and machine safety engineering experience, and he can help answer technical questions that might arise in our QA. So from here, I'll switch over to our presenter, Dave, and he can take it away.
Well, thank you, Jess, and hello, everyone. Again, my name is Dave Kerr, and thanks for joining our program today, and welcome to this MPSA Machine Safety Series. Today's program is focused around a common or a similar question that we have often received from many of our clients in our first few interactions. And this question is normally presented to us something like, how do I get my machine safety improvement program started, or how do I get my head and hands around such a program? And admittedly, I have to say that implementation of machine safety was one of the more challenging and complex EH&S programs that I was involved with in my career. Our reply to this question generally varies by the client based on their prior experiences, their in-house expertise, and any noted machine safety gaps or program needs they may have. But in the next 45 minutes, I will touch on some of the key elements and proven management practices we often share with our clients when they have presented us with this exact question. The goal of today's session and all of our MPSA Machine Safety Series is not to make you a machinery safety expert. That requires lifelong learning, but to familiarize you with some of the concepts, terminology, technology, industry standards, and regulatory compliance requirements that apply to machine safety, as well as share some of the proven program management practices that are successful for a successful machinery safety improvement program. Most importantly is that you leave this session with a better understanding of how to manage your machinery safety program and where you can find additional guidance when needed. As shown on a slide, here are some of the topics we plan to discuss in today's program. Implementing a machine safety improvement program has many challenges and complexities, and it can be a very daunting task. So before we jump in, and realizing that today's attendees may be at totally different places in the development or the management of their machine safety programs, we did want to ask everyone attending, what are some of the machine safety challenges you are faced with? What are some of the obstacles that are holding you back? And what are some of the difficulties you have found with actually getting started? So I just wanted to take a few minutes here to capture and post a few of these challenges so that potentially I can highlight some of these solutions throughout the presentation, or definitely in the Q&A session. So Jess, can you take over and just capture anything that comes our way for the next minute or so?
Absolutely. Yeah, thank you. At this time, you can raise your hand and I'll call on you to talk into your microphone, or you can type in the chat. And what we're looking for is a challenge or a difficulty that you've faced when developing or improving your machine safety program. And as Dave said, this will help us, highlight the different things that can address those challenges so you can move forward and be more successful. So I see some people typing in the chat. Tom Matko said resources is a challenge that he's received. Kyle said machine design, thermal energy exposure. John Z said trying to decide how to rank a hazard on a risk assessment. All right. Any other challenges? Let me check to see if anyone has their hand raised. So just taking a moment or two, Dave, do you have any comments relating to any of these challenges? Oh, I have a few more coming in. How does machine safety work with ISO 4500 is another challenge that CVAC has.
Yeah, I think we'll circle back. I think we can touch a little bit on Kyle with machine design, certainly with John on ranking a hazard in a risk assessment and deciding what standard to use. We'll talk about that. We may have to return to the Q&A for some details. I'll just queue up Jamie for the ISO 4500, let him think about that as well. And obviously we're in Bensalem, so this is Eagles country. So thank you from Pittsburgh.
Yes. All right. Very good. So yeah, we'll address these concerns. If not in the presentation, stay tuned for the Q&A, and we can readdress those more involved in depth if it wasn't thoroughly covered in the presentation itself. So thank you, and I'll turn it back to you, Dave.
Thanks again, Jess. So let's now walk through some of the challenges that other clients have encountered so that you have the benefit of learning what others have painfully experienced only after having dived sometimes headfirst into their machinery safety improvement journey, and unfortunately sometimes striking the bottom very quickly. First is the cost and complexity of machinery safety upgrades. Machinery safety is clearly more costly and complicated than purchasing personal protective equipment or implementing employee safety training programs. And I often mention to many clients that machinery safety and its complexity and its need for collaboration amongst many partners in your organization is analogous to really implementing a PSM type program. It just affects so many parts of the organization. Next are really the concerns that any machinery safety improvements can potentially impact the machine cycle times, thus negatively impacting production, productivity, or even quality. And that leads into the lack of stakeholder buy-in, at least initially. And this is often due to those stakeholders having the concerns, as we just noted above, but as well concerns with machinery access and reliability as well. There's also the limited technical support that may be provided by the original equipment manufacturer, often referred to as the OEM, or the equipment integrator or the machine's vendor. Then there's the discrepancies between regulatory compliance requirements and the industry consensus standards. Regulations are the law, and they typically offer, very sound basic safeguards, but the industry consensus standards may actually offer more effective solutions to both reducing the risk and ensuring more efficient machine operation. With legacy equipment, there's often the potential for limited technical documentation and antiquated safety controls and technology. And then lastly, there's limited in-house understanding of machinery safety, including both mechanical and safety control system solutions. So why is machine safety so critical? We've just discussed some of the challenges and complexities with developing a machine safety program. But despite these difficulties, it remains critical for all of your facilities to implement an effective machine safety program, or at least some key elements, if your facility operates any manufacturing, packaging, or material handling machinery, or even robotic installation. But what makes machine safety so critical? Well, first and foremost, serious, if not fatal, injuries can occur. These injuries often require emergency treatment, hospitalization, surgery, amputations, or sadly may result in an occupational fatality. Thankfully, machine safety incidences are not as frequent of an occurrence as other events, but when they do occur, serious, if not fatal, injuries result. Aside from the physical pain, machinery safety events are often a horrific experience for both the victim and any nearby coworkers. Coworkers often see the pain and trauma associated with these events, which can have a lasting and an emotional impact upon them. Also, employees who operate similar machines can become fearful that their machines may also be unsafe and that they may experience the same risk of injury. So, due to the high risk and seriousness associated with machine safety events, such events do draw the attention of regulatory compliance officials and insurance company field inspectors. And because of this increased attention, there is also the potential for regulatory citations and fines. Machinery safety continues to be one of the top 10 most cited violations by OSHA, as noted on the slide, showing OSHA's year-end 2019 violations. But in the end, it's the operation of the machinery in your facility that is key to revenue generation. And facility management is often of the opinion that any machinery safety incident or safety improvement project can potentially impact critical production or quality requirements. Hence, they may be hesitant to undertake any actions until a serious machine safety or a compliance-related event occurs, or they have complete confidence in the machine safety solution and those who will be performing the safety upgrade work. And because the stakes are high, what is most important here is that you immediately create the culture that proactively reports and investigates all close calls and abnormal events associated with machine operations. These events are often the accurate indicators of the more serious events that may occur in the future should proactive actions not be undertaken. So encourage your employees to proactively report and investigate all close calls and abnormal events associated with your machine operations. Following a machine safety incident, a serious close call, or a regulatory compliance citation, some organizations think that quick resolution of those issues becomes or is their green light to program success. But our experience has told us that fast track or quick fix type approaches often encounter many of the same challenges and limited effectiveness if not properly planned right from the start. So let's now discuss how to undertake some of the physical improvements for machinery safety and some of the considerations and resources needed. The first consideration is that machinery safety solutions vary by machine type, the hazards present, and how the machine is used or accessed by personnel. For example, automated and high-speed machinery and robotic installations often require complex and potentially costly solutions. Legacy equipment may also be complex and costly because of the lack of technical documentation and may require forensic control engineering to create such documentation before any upgrades can really take place. Machine shop equipment, on the other hand, is usually less complex in guarding, but still varies by the machine in use. Keep this in mind while developing your program and know that machine complexities may bring higher levels of complexity and cost to your solutions. This brings us to our next key consideration, your budget. As previously noted, machine safety improvement projects can be complicated as well as costly. In some cases, clients are faced with a high cost estimate for machine upgrades. In these circumstances, it becomes necessary to review the scope with management and determine what's the most cost-effective actions for your facility. And in many cases, the choices include upgrading the existing machine, maybe replacing the machine, or even outsourcing the work to a third party. So the correct answer varies from client to client and machine to machine. But having a clear mechanism to present such data to management that defines the regulatory and the compliance requirement gaps, as well as the other potential risk, is essential to making well-informed decisions. And this can help you develop a feasibility review process consistent with your financial guidelines and what best fits your facility's business model. So when deciding to upgrade your machine, it must not impact critical production needs or product quality measures. This often requires precise scheduling and planning that may exceed the capability of many in-plant teams and some third-party machine safety vendors. Who performs this work really does matter when it comes to a successful machine safety improvement solution, as they will need to manage the machine safety improvement project carefully around critical production or shutdown schedules. Lastly, for a truly safe and compliant machinery safety upgrade, any upgrades must properly consider all normal production operations and considerations such as the operator access and the effectiveness of each machine guard and safety control device for each operational task. To manage the service and maintenance requirements, as well as to satisfy hazardous energy control for a lockout tagout, each of the hazardous energy sources must be identified and properly controlled to achieve a zero energy state. And each of these tasks required a detailed review of the machine with your impacted stakeholders to carefully consider its use, its operational status, again, access and available controls. So let's now transition to discussing some of the proven management practices for establishing and managing your machine safety improvement program. Like all facility improvement initiatives, key program considerations must be well established internally and well communicated to impacted colleagues at your facility. As we all know, this is the communicate, 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 right? And the success of your machinery safety improvement program can be severely impaired if your senior management is not fully engaged and informed about these efforts. Management engagement and support is absolutely critical for developing a successful machine safety improvement program. But remember, you must effectively communicate both the financial and the operational impact of any machine upgrades to ensure success. So to establish program boundaries and incorporate everyone's interests, their knowledge, their support, we recommend establishing your own internal machinery safety advisory team with representation from key stakeholders. And some of the suggested stakeholders include the following: operations, EH&S, plant management, procurement, maintenance, engineering, automation or instrumentation, and even quality. Including machine operators and mechanics is also critical, since they often have the most day-to-day knowledge of the machine and its operational or maintenance needs. Providing some initial and introductory machine safety training for your team is also recommended, so everyone shares a similar understanding of machine safety. And since machine safety improvement projects can be large, complex, and costly undertaking, your program needs to have boundaries that specifically define the scope, the objectives, authorizations, and priorities. And please remember, not everything can be done at once. So this is where you'll need to think about the following. What machines are defined in the scope? What applicable regulations must be observed, as well as what industry consensus standards make sense? Who must review and approve such upgrades? And finally, how you're prioritizing the upgrades, whether that's based on compliance, risk, access, or budget. These are all key considerations when developing the scope of your program, and ones that will most likely arise during your machine safety improvement journey. So before any reviews or upgrades can actually be undertaken, your machine safety advisory team will need an inventory of the impacted machinery and assemble supporting documentation or supporting technical documentation. Many clients, especially those with older machines, are often not able to locate original machine design documentations and control system specifications, particularly drawings and schematics. So consulting the original equipment manufacturer, the OEM, is always advised to avoid any conflicts between any suggested safety upgrades in the intended or original operation of the machine. There are often sidebar efforts needed to gather or develop this missing documentation before your next steps can begin. So typical documentation needed to undertake a machine safety upgrades generally include the following: accident and near miss reports applicable to the subject machines, operating and instructions and maintenance requirements, any machine safety risk assessments or hazard identification activities, hazardous energy control procedures for applying your lockout tagout, original equipment or the machine manufacturer's design, operation, or maintenance instructions. Again, this may include drawings and schematics for electrical or the control systems, your management of change or mechanical integrity program records for the subject machines, and the safe distance calculations for any installed presence sensing devices such as light curtains, area scanners, pressure sensitive mats, etc. So let's now transition and define and discuss some of the regulatory requirements and industry consensus standards. Conformance with applicable regulatory requirements as defined by OSHA is always required. It's the law here in the United States. In addition to this, and depending on your industry and type of machinery, there may be specific industry consensus standards that should also be consulted. And many companies incorporate these industry consensus standards into their improvement specifications, since these standards may better reflect newer or current safety technology that may be able to further reduce risk and ensure more efficient machine operation. So you may need to comply with a combination or all of these standards, and developing this collection of in-house standards becomes critical for use when specifying, upgrading, or even purchasing new machinery in the future. In order to implement a machine safety program, you'll need to assess your machinery and identify the hazards and the risk associated with its operation. And one discussion to have with your management and your machine safety advisory team early on is the selection of your hazard identification methodology. You need to choose a type and a level of detail that best fits your program needs and expectations. Before conducting any reviews by your team, you'll also need to understand how to identify and how to address any of the findings that are identified. And there are several approaches to machine hazard identification. One is to conduct a machine safety survey, and the other is to conduct a machine safety risk assessment. And each method has its advantages, so it's important to understand each method and to choose what best aligns with your program needs and expectations. So when should you conduct a machinery safety survey or a risk assessment? What's the difference? Well, there really isn't a right or wrong methodology because it depends upon several factors. The first place to start is to consult any local regulatory requirements or your corporate EH&S group, or even your insurance provider, to see if they have any required or recommended methodologies. The option is to conduct a full-scale industry-recognized machine safety risk assessment, which will identify all hazards during all potential uses and conditions of the machine. This also evaluates the likelihood of an injury occurring and also the severity of such. These machine safety risk assessments normally use a methodology that conforms to one of the industry-recognized consensus standards, such as ISO 12100, RIA 1506, or the ANSI B11 or the 155.1. So choosing a machine safety risk assessment is never a wrong choice, since it is the most comprehensive form of assessment. This is a benefit of risk assessment, but it can also be a disadvantage, since there can be sometimes, or these can sometimes encompass more than what you actually need. So there may also be circumstances where resource limitations can prevent or delay the risk assessment really from being fully undertaken. And a proper safety risk assessment can require lengthy preparation and participation from several key individuals within your organization. Again, such as operators, engineering, EH&S, maintenance, and your automation or instrumentation staff. Safety risk assessments also require, again, the assembly of key machine safety documentation as noted on the screen. And anyone participating in a machine safety risk assessment should receive basic training, or at least an introduction on the risk assessment process. They should also be given time to research the machine's operation and the related technical documentation. The risk assessment methodology requires the team to methodically go through each machine task, function, or personnel access need. Again, this is a time and resource consuming effort that may require the team's effort for upwards of a full day or even several days on a large installation. And again, this doesn't include the time necessary to assemble and prepare for the risk assessment. Also, if a client hasn't managed a machine safety risk assessment before or recently, it would be likely advisable to use a trained facilitator to lead such an assessment. But once the machine safety risk assessment is completed, your observations will need to have a performance level requirement, or a PLR, assigned to each hazard or risk identified in the risk assessment report. And the PLR designation will allow a safety control engineer to design a safety control system that meets the required criteria and can be validated once installed. And again, this allows the original finding to either be eliminated or reduced to a risk that is suitable to your program. So as mentioned previously, machine safety risk assessments are very comprehensive and can take a lot of time to complete. So for smaller or simplified applications, a machine safety survey may be an appropriate solution. They are also a good tool for use while outlining the scope of your program, since the machine safety surveys can quickly identify costs and priorities for your improvement project, really without taking a lot of time and resources as compared to a full-scale machine safety risk assessment. The criteria for a machine safety survey is generally closely aligned with the OSHA requirements and the criteria outlined in ANSI and other industry consensus standards. Machinery safety survey questions are typically designed to assess in detail the safety and the compliance of the machinery during setup, adjustment, normal operations, cleaning, and repairs. Again, the machine safety surveys are generally less costly and take considerably less time to complete per machine. So it bears repeating that the use of a machine safety survey can be a helpful and cost-effective first approach to your machine safety program, as they can help to identify and prioritize scope and complexity for your program needs, including potential cost impact. Machine safety surveys are also very helpful to share with your management team to help them understand the impact and the potential costs while securing their engagement and support, which is critical for program success. The next practice is integration into your management of change and your mechanical integrity procedures, consistent with both EHS and quality requirements. We believe all changes to equipment and machinery should be subjected to your facilities management change and/or your equipment integrity program. So each change needs to be well documented and reviewed by each impacted group, and then approved and documented for consultation at the time of future change or upgrade. Our last proven practice touches on the machine safety improvement process, which is a proven practice that many clients have formally adopted after undertaking several machine safety upgrade projects. And this process can be modified to fit your facility's specific needs, but each of the main elements shown should be properly represented and staffed within your program. Let's discuss, as shown on the slide, the improvement model commonly recognized as a proven practice for successful management of machine safety improvement projects. The key is to understand what is involved in each of the elements shown and determine if such resources and expertise exist within your in-house machinery safety team or elsewhere, within your facility. So the first step in this process is hazard identification. And we discussed earlier, this involves conducting a machine safety survey or a machine safety risk assessment. Leading and documenting such efforts requires training and a bit of prior experience, which is why many opt to hire a machine safety consultant to conduct these initial assessments. But after the assessment is complete, we move to design. And most clients often only think about the design of hard or mechanical guarding made from metal, polycarbonate, or expanded screening. And while physical guarding is indeed an element of machine safety, the selection and design of safety control devices is equally important. And these devices include interlock switches, presence sensing devices, control reliable wiring, the safety relays, controllers, and more. So having knowledge and expertise in both physical guarding and safety control systems is critical for most modern day solutions. For facilities without in-house control engineering expertise, you will likely need assistance from a machine safety vendor with safety control expertise. So after the solution is designed, it needs to be fabricated. And some clients, again, may have knowledge and capabilities to fabricate hard or mechanical guarding in-house, but lack the expertise in assembling or fabricating the safety control systems, including the panels or the cabinets or the control reliable wiring configurations that are necessary. Again, if you lack suitable in-house control engineering expertise, you will likely need to seek outside assistance to assemble or fabricate the solution. Next comes the installation, which usually must be a very timely and well-planned event during a shutdown or an off-shift period, and precisely interfaced into the existing machine's process control or automation. Again, having in-house expertise may be a limitation for some facilities. After installation, you must validate the installed safety solution. And safety control systems today, by regulation, need to be validated in accordance with industry consensus standards such as ISO 13849. This process is far more involved than just simple fault testing of the installed safety components, and specific protocols need to be developed and executed post the installation by the safety control engineers. The last step in this continuous process is the train and maintain step, and each machine safety system will introduce new devices, components, and technology into machine operations and your mechanical support staff. So they will need to know or be trained on the operation as well as how to inspect or diagnose, repair, or replace components when needed. At MPSA, we offer machine safety training from general machine safety awareness to advanced machine safety control, as well as programs tailored to your individual facility needs. When planning to implement your machine safety improvement program, you need to ensure your facility has a commensurate level of capability and expertise in each of these areas. In some cases, this may require your facility to consult an outside or third-party provider like MPSA. So let's now review the information we have discussed so far today so that you can better meet those challenges and move forward with your own machine safety improvement program. First is obtaining plant or senior management engagement and support. It's essentially critical to have your management team well informed of the scope and possible impact, again, both operationally and financially, as you implement the program and specific machine safety upgrades. It may also be helpful to have some of those members of your management team participate in any initial machine safety training or orientation programs. Forming your in-house machine safety advisory team, training its members, and establishing clear lines for collaboration and involvement among its members. Assembling this team is critical so everyone is aligned on purpose, scope, schedule, responsibility, and their expected contributions. You will need to ensure that each member is well-informed and comfortable with the roles they're supporting within the improvement program. And this is really where some of the introductory technical training in machinery safety really may be valuable for some of your team or all of your team members. Identify your scope, including your budget and priorities. Once machinery type is prioritized, remember that conveyors and machine shop equipment, such as common metal or woodworking equipment, may be suitable for more common off-the-shelf type solutions. Larger and more complex or highly automated equipment, such as production, packaging, material handling, or robotic installations, generally require more custom type solutions. Verify that you have accurate and complete technical documentation for your machinery. Establish a technical file for each machine or groups of machines. This is critical and can be done in a hard copy or even electronic format where you can just simply point to who and where such documents are kept at your facility. If absent, contact the OEM or consider forensic control engineering to recreate some of these needed documents. But without complete documentation, your hazard identification, your design, your engineering, all those efforts will be compromised, clear and simple. Understand all the normal production operation needs, including the clearing of jams, making adjustments, the replenishing of supplies, etc. This is necessary for determining machine guarding compliance as well as other safe and effective solutions. You also need to understand the service and maintenance needs, including the setup, changeover, cleaning, etc. And this is obviously necessary to identify your lockout, tagout, and to ensure that we provide approved utility disconnects that provide the zero energy state for each hazardous energy source. Conformance with the applicable regulations is the law and simply must be observed, but depending upon your industry and type of machinery, there may be specific industry consensus standards that also need to be consulted. And many companies incorporate these requirements that are outlined in these consensus standards into their improvement specifications, since these standards often, again, reflect newer or current safety technology. And this collection of in-house standards does become critical when specifying, upgrading, or purchasing new machinery. Select and conduct either a machine safety survey or risk assessment, again, to identify your known or unknown machine hazards. This is often the time and resource limiting step, but an absolute critical one for moving forward with your machine safety improvement program. The methodology needs to be decided upon before undertaking any hazard identification activities. Remember to consult your local regulatory requirements, your corporate group, EH&S group, or even your insurance provider to see if there's a required or recommended methodology. Select an ISO, ANSI, or RIA approved methodology that provides the performance level requirement to PLR, as noted for hazards, is highly recommended. And please recall that the use of machinery safety survey is also a very helpful and cost-effective first approach to help identify or prioritize your scope, potential cost, and complexity of your program needs. So plugging the program elements into the machine safety improvement process allows you to create the scope, responsibilities, and process to ensure each machine is reviewed in a rigorous and a standardized manner. Remember that if you need help with implementing this process, the machine safety experts here at MPSA are always here to provide assistance. This brings me to my last point of discussion, and that is determining your in-house machine safety capabilities. And with recent industry downsizing and right-sizing efforts, many facilities may no longer enjoy having access to qualified machine safety personnel within their site maintenance, engineering, or their automation instrumentation groups. We define qualified machinery safety personnel as those who have obtained the designation through examination of a certified machine safety expert, or CMSE. So before embarking on your machine safety improvement journey, please take some time to assess if your in-house staff has the capacity and the expertise to support your machine safety improvement process. Knowing where your team's technical gaps exist and where CSME assistance may be needed is crucial for planning your program scope as well as the implementation schedule. So we hope that by listening to this MPSA Machine Safety Series has been informative and helps you to better understand how to get started or how to improve your current machine safety improvement program. So Jess, would you like to begin to facilitate the Q&A session, please?
Yeah, absolutely. All right, thanks, Dave. So it's time for our QA forum, where today's presenter, David Kerr, and our engineering panelist, Jamie Gehring, can answer your machine safety questions. So if you have a question that popped up in your head during the presentation, or another machine safety question that just has you stumped, now's your chance to get expert advice. So feel free to raise your hand, and I will call on you to unmute yourself, and you can speak through your computer microphone, or you could just type your question in the chat, and I can read it out loud to our panelist and our presenter to answer. So I'll give everyone just a couple minutes to type any questions that you have. It might be helpful, for me to go back and look at some of the challenges that people previously typed in as well, so we can address some of those. Tom said that resources is a challenge that he has. So I hope that after listening to today's session, this provided more resources for you to get started. And we'll be reaching out to you within the next week or so, to everyone who participated, with a recording of today's session to have as a resource going forward. So Kyle was saying that he has challenges with machine design and thermal energy exposure. So do we want to address anything further with that, Dave?
Yeah, I think I might want to pass that to Jamie because that's sort of in his wheelhouse, and Jamie is a legacy machine designer. Jamie, anything to add to Kyle's question?
Yes, I'd be glad to comment on it. It's one that we address occasionally. It's not one of the more common things that come up, but I'd say for the most part, with a thermal energy issue, you're going to need to have some kind of mechanical guarding or protection, which we would normally call some type of separation guarding. If the thermal energy might be exposed when an operator or personnel goes into a hazardous area, of course, it may depend upon the effect on the process. Can we shut the heat source off? If it's something like a flame, for instance, that's somewhat easy to do. If it's some other type of large heating element, there would be other ways that we'd have to address it. But I think separation guarding is the biggest thing, the way I would expect to approach that. So.
All right. Thank you, Jamie. Okay, another question that we had earlier today by John Z. John Z did have to take off, but he wants to listen to the recording, so he can listen to this later. But he was wanting to just know how to decide and rank a hazard on a risk assessment and deciding what standard to review for a machine that he's selling.
I think that first question that John Z has is a very valid question, and it's the reason why I brought it up in identifying and taking the time to identify the machine hazard identification methodology that best meets your program needs or your industry needs. And there's a little bit of research that needs to be done there by looking at some of those different methodologies, obviously consulting regulatory agencies or looking at maybe some industry user groups, as well as your insurance provider. Those are all things that you should really do. And then once you can look at some of those different methodologies, you'll see that the ranking for severity, the ranking for frequency and probability, there's different variations of that. And some organizations have sort of customized or changed some of the criteria so that when you do plug together your frequency, your severity, your probability, that the PLR that you produce is one that is reflective to their type of operations, and it's reflective to really the risk tolerance that's associated with their industry or their type of machinery. So there's a custom fit, I think, that really needs to take place when companies are selecting that. Clearly, there's some off-the-shelf ones that companies can use, But the more complex machinery, the more time I think an organization should take to look at that. And we're always happy to share some of our thoughts regarding that. Jamie, you want to pipe up on that? And do you want to discuss anything with standards to review for a machine they are selling?
Yes. Yeah, I think that it's possible that John may just be asking how to, and you touched on it, and that would be probably the severity of the injury. And in ISO 13849, they do reference what they consider a slight injury, which is just normally a reversible injury, requires only simple first aid, versus a serious injury, which is normally an irreversible injury or death and requires medical attention. Not sure if that's exactly what he's looking for. As far as the type of risk assessments and the documents, one that I really like is the robotics. And it's actually a technical report. It's R15.306. Last publication, I think, was in 2016. And it is a very in-depth process of doing a risk assessment, but a very, very valuable one to have. That would probably be my recommendation for that.
Very good. All right, we have a new question in from Kevin. This looks like it might be a two-part question. He says, from your experience with medium-sized manufacturing companies, where he says about 30 to 40 pieces of semi-automated and automated equipment, how long does it typically take to go from hardly a machine guarding plan program to a full-blown program? Also, how many additional resources did the company have to take on?
Great question. I think it's very dependent upon, obviously, the resources and the commitment that the organization has made. Obviously, getting that front end commitment by senior management so that they understand both the impact as well as the financials are critical. If you have the proper understanding of the scope and complexity of your program, and this gets back to the conversation about doing a machine safety survey versus a full-blown risk assessment. Getting in with the survey allows you in a matter of days for the 30 or 40 pieces of equipment you've referenced here to get your head wrapped around, what are some of the upgrades, what are some of the standards that are applicable, what are some of the hard guarding, what are some of the control system solutions that are needed. And it also allows you to get an idea as to how long will these upgrades take, how much will they cost, et cetera. That, I think, sets out a very firm plan for you and your machinery advisory group. If you have the right representation, I think very quickly that group can decide, is this something that we can tackle quickly? Are there some quick wins here? Or are there things that have to be done in the longer term? Do we have to break things up? So the way I generally answer this question is it's how well we make that initial presentation to management. And in order to make that presentation to management, we have to be armed with a good overall evaluation of what the fleet of machines currently present and what those gaps are. Once that's done, then it may be appropriate to go back and do risk assessments and then have some sort of schedule that can match sort of your quarterly financial opportunities. And you also have to bear in mind that whenever we do machine safety work, we have to take the machine out of service. So you really have to be able to work around production schedules and understand what manufacturing needs or what availability manufacturing can give to you for the machine. So that timing is very facility or plant dependent. Jamie, anything that I missed there in terms of sort of the high-end answer to that question?
You covered a lot of it, Dave. I think I would just add, though, I'm not sure if you touched on this exactly, as far as additional resources that you may need. I think that's probably a challenge. It depends on the type of resources I think you have to begin with, which Dave has alluded to, and that is, do you have technical people? Has there been reductions in your workforce for different reasons? So that's a difficult one, but I think starting out, if you use the resources you have, technical resources and others, you can get a start on this just without adding other resources to the company.
Thanks, Jamie. I missed that. I missed that last part there. And I think we had noted in the presentation a couple of times the real importance of a control engineering, whether it's in your automation, your instrumentation group, and particularly control engineering that has some familiarity with safety control design and operation, right? That's
Yes.
That's critical for in-house work.
Yes, it is.
Very good. All right. So there's no new questions right now, but I do want to circle back to a question that we had earlier during the challenges portion, which was how does machine safety work with ISO 4500? And this might be a good question for Jamie to address.
Yes, I'll be glad to do that, Jess. Thank you. Yeah, I know very little about the 4500. I think it's 45001, which is a occupational health and safety management system. I guess the machinery safety part of that is actually a component to that. In order to satisfy 45001, you need to do machine safeguarding and provide safety to your employees. But it by itself is just a component of that and does not normally, we don't normally address that particular ISO standard specifically.
All right. Okay, last chance for any additional questions. Give one more minute. All right, so I think that concludes our Q&A portion. So thank you guys very much for joining us today. And remember, you can get in touch with your partners here at MPSA by phone, email, or by visiting our website at www.mpsasafety.com. And we'll be reaching out to you today and asking you to take a really quick survey so we can make improvements for future webinars. We really appreciate the feedback, and it'll only take 2 minutes of your time. Thank you so much for listening, and stay tuned for more editions of MPSA's Machine Safety Series. I hope everyone has a really safe day.